Welcome, friends. This is day two of doing Codeforces until I reach specialist. And today's problems are covered in water. So let's try to solve this. Cover in water. Philip has a row of cells, some of which are blocked and some are empty. He wants all empty cells to have water in them. He has two actions at his disposal. One, place water in an empty cell. Okay. Remove water from a cell and place it in any other empty cell. So he has to remove water from a cell and he can place that removed water into another empty cell. Okay. If at some moment I, which is less than n minus 1, E is empty and both cells I minus 1 and I plus 1 contains water, then it becomes filled water. Yes, okay. Find the minimum number of times he needs to perform action 1 in order to fill all empty cells with water. Okay, we have to return a number which is minimum for which the all empty cells of all empty cells are filled with water. Note that you don't need to minimize the use of action 2. So we can use action 2 any number of times. Note that blocked cells neither contain water nor can flip like how the cells are blocked. So we would we have anything to show that the cell is blocked or not? So but this line says that at a cell I where I minus 1 and I plus 1 contains water, then that particular I cell is also filled. Okay. And now, so this is common. There are t number of test cases, which is less than 100. And for the first test case, it contains some single integer n. And the next line contains a string s of length n. The ith character of s is a dot. If the cell I is empty, okay, he say that if it is dot, it is empty, and if it is hash, it is the cell is blocked. So for each test case, output a the minimal amount of one needed to perform an operation. So let's try to understand the test cases. So here there are total 5 test cases are there, and for the first test case, the size of the string is 3. So here all the string contains all dots, so which represents the string contains empty cells, all 3 cells as empty cells. And second test case contains 7, so which says that the length of string is 7. Apart from that, it contains 3 hashes and 4 dots. So it says that okay, it contains 3 blocked cells and 4 empty cells. So like that, these test cases are going on the way. Okay, so for the first test case, the answer is 2. How the answer is 2? We have 3 empty cells, but the answer is 2. Let's try to understand. In the first test case, Philip can put water in cell 1 and 3. As cell 2 is between two cells with water, it gets filled with water. Okay, okay, okay. He mentioned this feature in the question. Like, so if at some moment I, so which is greater than 2 and less than n minus 1 is empty cell, and I minus 1 and I plus 1 cell contains water, then that cell also contain water. Understand? Okay, okay. I got it. So cells are actually starts from 1. So in order to become 2 is filled. So 2 minus 1 and 2 plus 1 has to be filled. So then 2 is automatically filled. So how many one operations we perform? We perform only 2 one operations. So we filled this one and we filled this one. So and then automatically these I is also filled. So that's what he's saying. Okay. So that's why we have 2. Okay. Now for these. even we have three block cells. So it doesn't matter how many blocked cells we have. It's only matter how many empty cells we have. So as we have four empty cells, but the answer is two. Guess why? The answer is two. He we already have the diagram, the question. So like see, this is represents a hash and dot and hash. So these three shows the blocked cells and these white cells show the hash cells, I mean empty cells. So first we place water in cell number 3. Place water in cell 3. Okay, we place water and place water in cell 4. I mean, not 4, actually 5. So, automatically these particular fourth cell, because 4 minus 1, which is equal to 3, so it is filled. And 4 plus 1, which is equal to 5, it is also filled. So, these 4 is automatically filled. So, but we perform two one operations here. As a result, we have 3 filled cells. Okay. And then the second operation, we are performing the second operation here. We are shifting the water from the fifth cell to the sixth cell. It's not mandatory. Yeah, it's not it's not mandatory to say that we have only allowed to take water from the fifth cell. So we can take water from the third cell or from fourth cell. It's our choice, but we can keep it on the non-empty cell. So that here that's operation is performed. So move water from cell 5 to 6. Okay. Then here 5 cell is contains water. So now, I mean, actually 6 cell is contains water. So 5 minus 1 is actually 4 and 5 plus 1 is actually 6. So as a result, 5 contains also water. Understand? So yes, this satisfies the property. Second. So and we have only written how many one operations we perform. So we are writing these two, right? And yes, I think it's so simple. And for these two, there are no consecutive three blocks. Yes, this rule only applicable for when we have consecutive three blocks of empty cells. So as it don't have, we just have to fill the each and every empty cell. So one, two, three, and four, five. So the result is five. Yes, that's right. That's right. And here all are blocked, so we don't need to fill. So that's why it is 0. Okay, like it's a kind of edge case, right? And for these three, so yeah, this is again 3 is available. So we first filled the first and last one, so it fills the middle empty cell block. So so we are using one like one operation two times. So these three are filled. Now we have to shift this to this one. Like even if we shift this to this one, so it is filled. And we have to fill this also. Why it's taken two only? I don't understand. So we have three. Okay, completely okay. So we can move. We can move to the so that. Oh, we have to fill all three, right? In fifth test case, there exists a sequence of actions that requires only two types of actions. Two types of actions. So by the way, I don't understand even this test case, but we have to solve this in that way. Whenever there are three consecutive empty cells are appear, so we just have to return two. So because we are performing one operation two times whenever three test cases are available. If not three test cases available, we return how many empty cells are available. If that's not if all are blocked, we just return 0. So let's try to solve this. Okay. We have to take the test cases and read the test cases and read over the test cases many times there. And then we have to take the string. Sorry. We take the length of the string, directly string. The contains a single integer and the number of cells. Okay. And then the next line contains a string of length n. Okay. So we have to take the int n. So which contains the string of n. And this is string we are reading that string. Okay. So fine. Now, so first we have to iterate over that string, right? To find how many dots we have. So iterate over the string. We have to find the characters, right? So in total characters equal to zero. I mean total dotted characters. So because dotted only represents how many episodes. Okay. Yes. We have to find the dot characters. So if character is equal to dot, then total dotted characters plus plus. Okay. So I think firstly it's better to find whether the three consecutive blocks are present or not, right? So for that we have to iterate over the string plus then ni plus plus. Okay, so now we have to iterate over this. So first three are consecutive blocks. So if I start from zero, so 0 plus 1, 0 plus 2, it's a kind of risky, like may cause out of bound condition. No, but we have to decrease these also. So otherwise, we can start from 2 directly. So because 0, 1, 2 are three indices, right? Okay. So starting from 2, I'm up to the end of n. So what I'm calculating if um, directly I have to know whether there are three consecutive white blocks or not. So S of I, actually S of I minus 1. So actually I minus 2. So 2 minus 2 0. So is equal to dot dot. And S of I minus 1 is equal to dot again. And S of I minus, okay, just I, because we already taken 0 and 1. Now we have to check 2. So it equal to so if all consecutive three blocks, then we just have to um, print out answer is 2 goon and then and like we don't need to break should we break it we have like written so the code only executes up to this. I'm sorry. If I had continue here, it causes this much uh, like breakdown, right? Like breakdown. So we just try to use all test cases. So if three dots are available, so we just print it out. Okay. So okay, this okay. So we just print how many total dotted characters are there. And so only among these two conditions are applied. So for that, will b is equal to true. We taking that, and if mm, so like false. So whenever these exist, this won't exist. Equal. If b is equal to true, then only run. Otherwise, if b equal to false, okay. So directly continue. So like this total part after the b is equal to false condition is true, so it won't execute because I'm using continuous trigger, right? So then, otherwise, if it is not printed, signs that then so you have to find total characters and print them. If they are not, I think it can handle the other two test cases. Let's try to, you know, run. Ah, oh, so I'm just printing the string that we have to return the value which is present in the string. Two 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 502 two 502 502 why like another condition another test case is there, so we have only five test cases. 22502, so there is no need to print we are printing two twos. Why? Okay. So after this executes, it's going to the next test case, which takes another string and another one, which is seven. So total new string, right? So for this, it finds. So this is also true, and it won't have fire. So 22502. 22502. We have two twos, but why? Why do you have it? So I'm only writing. Okay, there must be some issue with my code. Okay, but what is it? Mm, what is it? The next line contains a string s of length n. I the character of string. Okay. The first line contains number of test cases. Description of test cases follows. Uh, you don't need to minimize the so 2 n minus one. Okay. Less than n means it actually okay for minus one. But why two, bro? Why two? I'm not understanding. Is it only Wait. What if we do like so it is to so that is just adjusting. So that's right. It's not presenting this. So for fire, it takes five test cases on it, and five minus next becomes four. So for these five, it takes three read three integer and read string is three string. Okay, and b is equal to true. Then okay, this is just say that okay, I'm condition verified or not verified like that. This boolean value is use it like that condition. So if for so from starts to less than n. Okay. So this count to 2 and b false. If b is equal to false, you have to continue to another condition. You don't need to print this. Otherwise, we have to find how many dots are there. One, two, three. So this only executes three times. So for the test cases, this. So for three, it reads string and print result like for two, and for seven, same. And for this seven, if even it is executes, uh, the zero won't come, right? So but 502 exactly came. Let's find GCB is okay, but I think it will work. Okay, so run. So let's say it's let's just hold it. Any input goes here. Shit, we have to give our input also. Then let me back. Straight input. Phone. GFG. Huh? Ah. No. Don't worry. Let's find out. Let's find out this. 3, 2, 1. Okay. It actually gives those three twos, but here 1, 2, 5, 0, 2. So they must house some wrong in my code. But where is it? Why this true print line actually performs two times? Why? So, why? So So it starts from 2. So 2 minus 2 dot and 2 minus 1. So 1 dot and 2 it is dot. I'm so sorry why I'm such a lame person. Okay, we have to break after this. We don't need to execute the for loop again, right? So that's why. So the for the test case, this one for this test case, it actually prints 2 times 2 because there are 4 empty cells are available. First 3 it prints 2 and next 3 it prints 2 because for loop actually increments only one value at a time, right? So now our code gives right answer. Yes, of course. So let's submit this answer. Yes. Oh, we have copy option. Is it copied? By the way, in yesterday's Codeforces Div 3 context, I only managed to solve only one problem. Actually, I figured out how to solve two problems, but I'm out of time. Yeah, running on test cases. 9. Yes, it's accepted. Good one. And let's go to the next one. Is it yes, really we saw this one. So what is present in this one? Have you figured it? In cover in water? It also depends upon the test cases. We read the test cases more, and then the problem. It is such an interesting problem. We have to know how many times we are using one operation here, and it's all depending upon these line, right? If these line, it's a kind of like a future. So if this feature is satisfied, we have to print only one the answer 2 as an output if this feature is satisfied. Otherwise, we have to print how many there, how many are empty cells are there, right? So now let's go to the another one game with integers. Yeah, wow. So Vanya and Boa are playing a game. Players are given an integer n. On their turn, the player can add 1 to the current integer or subtract 1. So we can add 1 or we can subtract 1. I mean, the player can add 1 or subtract 1. Two players take turn. The player takes turns. Vanya starts. Okay, so he is the one who started the game. So if after Vanya's move, the integer is divisible by 3, then he wins. If 10 moves have passed and Vanya has not won, then Vova wins. Okay. So like after performing the operation has to be performed, right? If that number is divisible by 3, then he's the winner. Vanya is the winner. Otherwise, the other player, Vova has the winner. I mean, not otherwise. After performing 10 times this operation, even if Vanya is not win, then the Vova wins. And write a program that based on integer I and determines who wins if both players optimally. So here optimally it says that if either of the player has a chance to win, then that player won't misuse the chance. Like if I'm the Vanya and you are the Vova, and the integers are like why so hard? We will find it in the test cases, right? So T test cases and the single line of each test case contains the integer n. So from where we have to start the perform operation. If Vanya wins, we have to print first, and if Vova wins, we have to print a second. As so for The test case one. For the first test case, the n is one. So if I add one to it or subtract one from it, I can get one or zero. One is not divisible by three, but zero is divisible by three. So one year wins. So first one clear. And for test case number three, so if I add plus one to it, I can get 4. If I subtract 1 from it, I can get 2. So the integers are like 2, 4. Both are not divisible by 3. And then if the number is 2 and if the number is 4, two types of operations, like two types of conditions are given to the OVA. So that second player, and so he can either add one, he can subtract one from that. So let's say that he taken two, OVA takes two. So two plus two, one, two plus one, that is equal to three, and two minus one, that is equal to one. One and three. Okay, one and three. So if I'm the OVA, I'm the second player, and I know that if I gave Oh, three. I gave a number to him, to the first player, which is divisible by three. So definitely he is the winner. So then why I am giving that number to the first player, right? If I have a chance to win, then I'm preferred to win rather than lose, right? So I don't give a chance to the first player. Definitely I will give like unchance to it, like unbiased, sorry sir, not unbiased, a number which will not perfect him, which will not him to make win. Okay, and so for three, second player is the winner because after performing the operation he must lose. And for five, okay, first, because why? 5 plus 1 6, so divisible by 3. 100 minus 199 divisible by 3. So first, but 999, 998 and 1000 both are not divisible by 3. So second one, and 1999 divisible by 3. So first, so it's a kind of we just have to check whether the number, we have to reduce that number and check whether it is divisible by 3. If it is divisible by 3, so okay, boom, the first player is the winner. And if it is not, so we have to increment that number plus 1, and I have to check it again, divisible by 3. So if it happens, then we have to give first player as the winner, otherwise second player. I thought like I'm getting that into my mind. So let's try to solve in that way only. So we have to read n, and like if n minus 1 divisible by 3. So or n plus 1 divisible by 3. So we have to print first one. First player is the winner, right? Else. So if he is not the winner, we thought, okay, second one is the winner. For all these test cases. Don't I have any output? Oh, we have what we have here. I'm so sorry. I'm so sorry. I'm so sorry. We have to check it whether it equal to one or not, right? So if it is zero, in if condition contains zero, treat it as a failure case, isn't it? So now let's check again. See out first and ln. Oh, again, sorry. Here it is and ln. The presence enter into this line is entered. Just go to the next line to the controller. So first, second, first, second, first, second, first, second, first, second, first. Mm, same. Let's try. Let me read. So we just have to print first F as okay. We have to print in that way, in this way. We don't need to, we don't print all letters as capital letters. Uh, it may cause first, second, first, second, first. So now let's submit this answer. I wonder if it is taken. Yeah, it causes definitely not satisfied. This code not satisfied, definitely, of course. Why? Because uh, we have a condition. This has to be rotated 10 times. Understand? So these if condition has to be checked 10 times. If 10 times is happened, then only the second player is winner, right? So let me say we have an iterator like 10, 10, and while I greater than 0. So 10, 9, 8, 1, 6, and I minus minus. Okay, cool. So now if we read the question, we can get that. We can get it. You see, if after Vinay moves the divisible by 3 after checking, if he is wins. 10 moves have passed and Vinay has not win, then over win only. Right? Else part. Where is else? Oh, sorry. While else is not a context. It's not a loop. Um, if it is printed, this is not printed, right? I can decrement. Uh, huh. Like take j is equal to 0 and j equal to 1 and if j equal to 1 only, j equal to 0 only, so the inner loop, the inner this condition is not actually satisfied. Once it is satisfied, we have to break. We don't need to run. First, second, first, second, first. I wonder this can this can even show this could even show the errors. Let's try to submit the code. We'll know after submission. 3, 2, 1. The major default in this, we don't know the hidden test cases in Codeforces, right? But it's accepted. Wow, that's cool. Let's try to solve the another one because in 39 minutes I am capable of, I know today I'm solving only two. So let's try to solve this. Okay. Jagged swaps. Jagged swaps. What is it? We have given a permutation. What is the symbol denotes? I think I often see this symbol whenever after the permutations in a lot of coding contests. Like no, there is no particular say. So A, given a permutation A of size n, you can do the following operations like from I to from 2 to n minus 1, such that if I minus 1, A I minus 1 less than AI and AI greater than AI plus 1, swap AI and AI plus 1. Determine whether it is possible to sort the permutations after a finite number of these operations. What are those operations? We can swap A and AI plus 1. When we can swap A and A plus 1 for index I, so it has to perform from 2 to n minus 1. Why it starts from 2? It's simple. Because we have to check whether AI minus 1 is less than AI and AI is greater than AI plus 1. Like, so we can know more about this in the test cases. So don't worry. And a permutation is an array consisting of n distinct integers from 1 to n in an arbitrary order. So how can you say that it's an arbitrary order? Arbitrary order is like see 2 3 1 5 4 is a permutation. So he called that this is a permutation, but 1 2 2 is not a permutation, and 1 3 4 is also not a permutation. Why? So 1 2 2 here 2 appears times, so definitely it's not a permutation. If same number is appears twice, is not a permutation, and is not a permutation because 3, but there is a 4 in the arrays. Okay, here arbitrary means uh, it contains elements from 1 to n. Like so let's say this is size 1 2 3 4 4 5, so it contains 1 to 5 elements, then only it can say it's a permutation. Here the highest number is 4, but the length is 3, but it contains 4. So then it's not a permutation. I think you got it. So if the highest element is not the actually equal to that length of that list, then it's not a permutation. See here, the highest element is 5 and the length of that list is actually 5. Then so it's a permutation, bro. Okay, I got that one. Today I'm no, so how can you define a permutation? And the test cases regular, we have to read an integer and second line contains the integers from AI to n, the elements of permutation A. Okay, so this is the size elements of permutation A. Size element of permutation B. Size and element of permutation. Okay, we can sort them. Otherwise, no. So let's see. So as it is sorted in order of sort. So it can sort 1, 3, 2, 5, 4. It can sort, but can't sort. It can't be sorted. It cannot be sorted. Even it cannot be sorted. Why? Let's check in our whiteboard. I called my paint as a whiteboard. So whatever. So let's see. Uh, what we have. So let's first I want to know whether 1 3 2 and 5 4 can be sorted. Like see, so the only way to sort an element is when array of yeah at the index I is I minus 1 is less than element at I minus 1 is less than I, and element at I is greater than I plus 1. Then we can swap these I and I plus 1 elements. I think this what we have here. See, yeah, this condition. Element at I minus 1 is less than I. And the element at I is greater than I plus 1. Then swap these two because I minus 1 is actually less than I. So no need to disturb that. And I is greater than I plus 1. What we in order to say it's a sorted, I is less than I plus 1, right? So yes, this is the condition. So we have start from here, index 1, not 0. and up to the n less than n index. So we have to check whether this 3I is less than I plus 1. Ah, yeah, bro, yes, it is. And if it is greater than I plus 1, yes, of course, 3 is greater than I plus 1. Okay, these two was satisfied. So true, we have to swap. So we have to keep here 2 and keep here 3. So now the contains 1, 2, 3, 5, 4. Now we have to increment from 1 to 2 index. So check this. So 2 is less than 3, of course, and 3 is greater than 5. No, it's not. So increment I. So 3 is less than 5. Yes. 5 is greater than 4. Yes. So swap it now. So it becomes 4 and it becomes 5. Right? So now the list is 1, 2, 3, 4, and 5. Yes, it is sorted. Yes, it is sorted. So that's why for this, true is answer. Okay. Then why it can't be sorted 5, 4, 3, 2, 1? He say that we have to start from here. So in order to swap these two, I minus 1 is less than I. 5 is less than 4. No, false. So we are not able to swap these two. As a result, it can't be sorted. Okay. And then 5, 1, 2, 3, 4. Same. 5 is not less than 1, so we are not able to switch it. And 2 is less than 3. Oh, yes, it is 2, 3, 1, 4. Let's try to check this test case. 2, 3, and 1, 4. Is 2 is less than 3? Of course it is. And 3 is greater than 1? Of course it is. So we have to swap these two. So 2, 1, 3. Okay. Now 3 is less. Okay, 4 is actually there. And initially we are checking this. Now we have to move to increment our index. So we are right here. So that means we are right here. So 1 is less than 3, F. And 3 is greater than 4? No. So not. So move our pointer. So 3 is less than 4 and already the elements are, there is no other element to check. So now the array contains 2, 1, 3, 4. Is it sorted? Is it sorted? See, is it sorted or not? It's not sorted. So that's why we are giving no answer. Okay, so here the first element is 5, 2, and 3, and 4, and 1. Come on. So whenever the first element is 1, it is S. So that's what we get from these test cases. Let's try to build a new test case from that and check whether it actually true or not. So 1 and so 4, 5, let's say that 4, 3, 2. Okay, it is a permutation because the highest number is 4 and the length of these array is also 4. Imagine this, imagine that this is an array and we have to start from this index. So check 1 is less than 4, right? And 4 is greater than 3, right? So swap it. So 3 and 4. Okay, and increment here. 3 is less than 4. 4 is greater than 2. So swap it. So 2 and 4. Now we have 1, 3, 2, 4. It's not in sorted order. Perform the operation again. Okay, so 1 is less than 3, 3 is greater than 2. So swap. So 2 and here 3. Okay, so 1, 2, 3, 4. Yes, it is swap. Yes, it is. But in previous one, we have to perform that operation again, like in circular way. We have any option? We have, but in question there is no one say that we can perform the operation. How many times we can have? So we have permutation. Okay, whether it is possible to sort the permutation after a finite number of operations. After a finite number of operations, yes, we can perform. But we don't know that the finite value. But we can perform the finite operation again and again and again until you get the answer. But let's see. So this 2314 can also be sorted after performing finite operations like this one 1432 array. So 2314. So here 1 and here 3 and 134. Okay, no, no, not too much. Apply the operation again. 213. As it's right. We can't move from this, right? So here, because 2 is not less than 1, and besides 1 is also not greater than 3. We are stuck here, right? So that's why it written now. Okay, let's try to code it. I'm completely understanding the intuition behind that. So we have to read n, right? So we have to read n, and after reading n, and we have to get, uh, create an array. Oh, sorry, an array of integers, array of size n, array of size n. So now we have to read elements into the array. So for that, scene, mm, array of five, right? Good one, right? So I'm just pushing the elements into the array now. Now. So we have to check whether the first element is one or not. If it is one, okay, it can sort it, bro. It can sort it. Otherwise, it's not. So simple. So if a of 0 equal to 1, see out is as, bro, we can sort it. Else, we can't sort it. Sorry, I didn't give this question specification. S okay, remaining unknown. This is what we want. And then, like, let me submit this code and check actually it is taken or not. 3, 2, 1, 2, 2, 1. Running on test case 1. Running on test case 1. And it's accepted, like, okay, I'm fine. I'm happy today. I'm able to solve 3 problems from 800. It's like, how can I say? If you can solve all these 31 problems, you can solve the first question from Codeforces context. Every contest, because every contest have these levels of questions. One must be from 800 question, but it's a kind of tricky. We have to understand the question first and understand the test cases. Then it is easy. So, and thank you for all watching this video.